Okay, let us start with the Indian part of syllabus. The physiography, when we talk about physiography is nothing but the landforms. India can be divided broadly into five types. First, we will start with the Himalayan region. This is Himalaya. Second is the northern plain. Third is the peninsular India. Fourth is the coastal plain. Fifth is the islands. These are broad division of Himalaya. Now, I won't be discussing all those how this has been formed, but let me try to explain you some important points regarding with India. It will be physical, and it might be cultural, it might be economic, it might be multidimensional. Okay. Now, Himalaya come out of great geosyncline. You know what is geosyncline? See, suppose a large scale depression in Earth's crust containing very thick deposit. That is geosyncline. But please try to remember these statements. Large scale depression, thick deposits. Suppose in exam they ask you define geosyncline and all. Say, you know this one. You know what is depression, and there was a depression. There is very thick deposit also. But suppose if you miss out geosyncline, it might be a very tough concept. That particular question is completely missed. So in order to get maximum mark, you just remember this. Geosyncline is this, uplifted in different phases. So while this is India, while it was coming towards the Eurasian plate, this is a water body. Sedimentation took place on both sides, from Eurasian side as well as Indian side, and there was a lot of thick deposits, and that was known as geosyncline. Geosyncline was removed and there was a formation of Himalaya, and that is how India has come out. Now, there is different phases. What are different phases in the formation of Himalaya? Because Himalaya, as we all know, consists of three parts. The greater Himalaya, the middle Himalaya, and the recent one, the shiwalik, or the less Himalaya. Now, why they are called different names? Because they have been formed in different phases. This, for the greater Himalaya, formed in the first phase, so it is one of the oldest, and the middle Himalaya is the second, and this is the most recent, the third one, the shiwalik. Okay, so in exam, suppose if they ask you what are the different phases of Himalaya mountain formation, your answer is very simple. Okay, why arcuate curve which is convex to the south? See, you just see the structure of this. If you travel from this northwest to northeast part, from here to here, just imagine the southern part. It is not straight. There is a curve, means there is a bulging on this place, on this side. There is a bulging. Anyone, do you know why this one? Why this particular shape? Because see, this is a possible question, because last time they asked about why no dalda formation on the western coast of India. So you see the Indian physiography, there might be certain special features, and the question can be revolved around that one. Why? See, the reason is, see, look, imagine, okay, see, we have a very powerful imagination, human being. That is the only reason it is, keeping us occupied with our study without playing Navratri, without going for Diwali occasion. Because we imagine one day we will be collector, so we study today. Okay. Now, divert that attention to this example. Okay. Suppose, imagine there is a iron rod of 100 centimeter, 1 centimeter, 100 centimeter. I am applying equal amount of force, say 1 Newton, and I am pushing this, and there is a landmass or any other object. I'm pushing this. Example, there is an object. I'm pushing this. I apply 1 Newton, it will touch here. 1 Newton is very small. It will also touch. Now, if I apply 50 Newton, it will push this substance. So there will be this displacement. Displacement, right? There will be a displacement. What will happen to this? 1 centimeter is too thin a rod for 50 Newton. So this rod, instead of pushing this, it will itself bend. So there won't be any motion here. Right? Now, so what is the final displacement? On this both the side, it has already been moved. So if you connect this, isn't it an arc type? Understood this? Yes. So you have understood this also. Now, in the peninsular region, you have this Aravalli. On the eastern side, there is a Assam range also. Okay. So, you have two huge landmass on both the side. One on the western side, one on the eastern side. And while it was hitting on this Eurasian plate, both sides exerted. But on the middle side, because of lack of mass, it was not able to push. That's why this bulging happens on the middle part, while there was excess pressure on the both sides, and that is how the shape of Himalaya is arcuate on the south. It's convex on the southern region. Clear? Clear? Shall we go ahead? No, because see, I did my engineering in Maharashtra. So what happened is, when I went there for the first time, we were just sitting in the class. I belong to northeast part of India, so out there we say yes means like this. Okay. When I went to Maharashtra, the teacher was speaking and my friend were sitting, and the teacher was asking, "Are you getting the point?" Something like that. So the students were doing like this, and both are very happy. Okay. I used to wonder. The teacher is asking, and the students are saying no, and both of them are happy. How it is? So is it like this or like this? Now, okay, this is clear. Okay. Okay. Now, what are the evidences to prove that Himalaya are still rising? See, quickly, okay. Himalayas are rising. That is a known phenomena. But what is the proof? The proof are very simple. See, fossils formation found in the shiwalik hills are also available in the Tibet plateau. Why? Because this is shiwalik at present. This is Tibetan plateau. Now it is saying one of the evidences, this deposit that is found in shiwalik is also found in at present. This is shiwalik. So there is a special type, there is a sediment formation here specific to this climatic geographic location. Now this same sediment, how it is present in this Tibet plateau? So it is considered that once upon a time, long back, this Tibet plateau were in the same location like shiwalik is today. Understood? So that is one of the reasons. Means what? This Tibetan plateau were at the same level like shiwalik, but it was uplifted. So that is one of the evidence how Himalaya is uplifting. Okay. Reasons, evidence to prove Himalaya are still rising. Second is desiccation of lakes of Tibet. Because see, Tibet, the height is something around 4,000, 5,000. So, in Tibet, we find a sand, this one, lacustrine deposit that were found in the lakes. But lakes are absent. So what is the reason? Once upon a time, in Tibet plateau, there was a lake, but because of upliftment, there was a discharge of water. And only the deposit remains. So that is desiccation of lakes of Tibet. Frequent earthquake that you know, because when there is a movement, there will be an earthquake. Youthful nature of river. Youthful nature of river is high erosion, formation of V-shaped valley. On the other hand, on peninsular type of river, It is a very old river, okay. How does Kashmir Valley is formed? Very simple. In Pleistocene age, okay, this is the last ice age. It was a synclinal basin. See, this is anticlinal, the upper part, lower part is called syncline. So it was like this. Kashmir was in like this. It was a lake. There was a glacial deposit because it was in the last ice age. But because of the rise of Himalaya, it has been raised up. Water has been discharged, but the sediments remain. So we find glacial deposit also, okay, and lacustrine deposit also. There is a name, Karevas, okay, same thing. What is the potential of minerals in mineral oil exploration in Himalayan region? See, it has been, we'll just go back. Look, it is an ancient landmass, archean formation. So it will be rich in all the minerals, coal, that's why we get coal in Karnataka, or any iron and steel, in metal, especially the metallic deposits are found in archean type of rock formation. See, and second, marine deposits are very important for petroleum formation. Secondly, because of vegetation and subduction or upliftment, coal will be found. Okay. Now, when it came, there was a heating that took place, upliftment. So some of this part also uplifted, some of this part also uplifted. At the same time, the deposits were also uplifted. So there is a possibility of having a lot of, see, coal is found in Kashmir. Coal, copper, lead, silver, etc. are known to occur. It's very rich. But there is a limitation. Limitation is about present level of technology. And this is the only answer, nothing else. Because see, even in the Gangetic Plain, we know the reserves are sedimentary reserves. Because once there was a tethys in the entire Gangetic Plain. So there is 100% possibility there is a petroleum. But today we don't have a petroleum field in those Gangetic Plain. What is the reason? Because at our present level of technology, we cannot drill to that depth. And even if we can drill, what is the economic feasibility? You drill, you spend, say for example, 500 rupees per liter, and after coming up you sell it for 100 rupees. Can it be a sustainable? No. Right? So those are limitations. Otherwise, geologically, it is possible. Here, all the regions are very rich. You say Dehradun. So dunes in western region, duars in the eastern region, Sikkim, Nepal and all. Okay, what are those? Dunes, Dehradun is a valley. How it has been formed? I'll tell you. There was a river and the river were passing. Imagine this is not here. Okay. Now what happened is, gradually, because of tectonic activity and shifting of India towards the Eurasian plate, mountain rise. And especially after middle Himalaya has been raised, gradually the shiwalik range came up. This is a shiwalik range. So the flow of river has been obstructed completely. When there is obstruction of any flow, there will be a formation of a lake, stagnation of a water. But when there was a stagnation of water, gradually erosion took place in this part. Because see, it is not like tonight you slept, and tomorrow early morning you wake up and there is a mountain. Okay, it is not like that. It was a gradual. So it was a process. Means the mountains are building up slowly. At the same time, the river also accumulation. At the same time, erosion were taking place. So everything were working one after the other in datum. Okay, one after the other, just like a system. So what happened is, it will gradually find some weak spot. Water will be drained out, and after draining out, the remaining valley, that is known as dunes. And since it is very dry now, human settlement began to stay in this place. That is how dunes in the western region. This is formation. Duars in the eastern region. Okay. Now, monitoring of glacier of the Himalaya. This is very important. Monitoring of glacier, because of global warming, glacier melting that is taking place in Himalaya is becoming very important. And once that glacier is melting, the activity that is happening downward, flooding, destruction of life, destruction of water bodies, destruction of entire ecosystem on the downstream, it is possible. So try to remember this: glacial lake outburst flood. See, this will be a lake. You have studied the landforms of glacial landforms. There will be a terminal moraine or end moraines, and there will be obstructed, okay? But sometimes it will burst, okay? Sometimes because of many factors, anthropogenic factor, geological factor, earthquake, something like that. And when this water comes out, and this is like huge reservoir, okay? It is as good as a river or a very, very big dam. So when the water releases from here or comes down, there will be a complete destruction of life and natural vegetations, and it will completely affect the river regime downstream. Once the river regime of the downstream is affected, it will affect the flora and fauna of this particular region. And by affecting the flora and fauna, it will affect the economic of the people that are dependent on that flora and fauna. That is how it has been linked up. Everything is linked to one another. So triggering in one will affect the entire chain. It is just like a system. System consists of many subsystems. Any effect that is, or any change in one subsystem is going to affect the entire system, entire other subsystem. Same thing in geography. So now, what is the mitigation process? How to mitigate such? One is about tunneling. These are engineering practices. But at all, if they ask about mitigation process, tunneling diversion means, suppose if the end moraine is very strong, we can put a tunnel, discharge the water continuously, so pressure has not built up. The second is diversion of these to other resources, for irrigation purpose, for any other. Okay. What is the chief characteristics of Great Plain of North India? I am not going to discuss this is west, this is east, something like that. I'll tell you the chief characteristics. See, 200 meters is the mean sea level, in this part, on the eastern. 291 is in this region. Now, from this region to this region, it is somewhere around 2000 plus kilometer. Now, in covering 2000 plus kilometer, the difference is only 91 meter. Means what? It is very monotonous. It is very plain. It is very plain. Gangetic plain is very plain indeed. But one of the very important feature is it has a water divide. In spite of the monotonous and in spite of the plainness of the surface, there is a water divide. And that place is known as Ambala. Ambala acts as a water divide between the Indus and the Ganges. Okay, that is one of the chief characteristics of the Great Plain of India. Peninsular plateau never accept marine transgression taking some place. Kutch region is one of the best examples. Okay. And Rajasthan, even Rajasthan. Why petroleum is found in Rajasthan? Because of transgression of seawater into the land. It's one of the factors. That's why there is a formation of petroleum, hydrocarbons. What is the evidence for taller height of Aravallis in the geological past? We say Aravalli was much higher than today. Then what is the evidence that we have? The evidence that we have is the glacial deposit that is found in Aravalli. Today if you go to Aravalli and if you are a little bit aware with the geology and all, you collect the sediments or the erosion surfaces and all, you will find a glacial deposit that has taken place. So at this particular latitude of Aravalli, how that is possible? The only thing is it needs to be very high, because Aravalli, the traveling of Indian plate was not from the northern side to the southern side. Indian plate traveled from north side to the from south side to the northern side. So if we travel from south to north, temperature decreases, not increase. So, but why that particular glacial deposit? The only reason is it should be very high. Only then there will be a glacial deposit. That is one of the evidence rather. Reasons for steep-sided, flat-top hills or cliff presenting the mesa-like steppe topography facing the Arabian Sea coast. When you go, many of you, if you have traveled across the Western Ghats, you will see the topography like this, steep. Okay, there will be a water body, the Arabian Sea. It is not gradual or something like that. It's very steep. The reason is, can you see this? This is just like a table form. This is called mesa. Mesa is a table form. Its formation is like this. When there is a hard surface, it is very hard and not so hard on this side, or even if it is hard, erosion, the main point is erosion will not take place from this side. Rather, erosion will be from lateral side because this surface is very hard. So after erosion, after many cycles, it will be a tabular kind of landform that will form like this because it has been eroded. Because erosion from the top is not possible because of the hardness. So it will be kept by a hard rock, and after that this might be a soft rock or of the same nature. But the main thing is the landform is just like a table landform. Means cliff. If it is a water body, this is a cliff. So it is Arabian Sea, this is a Western Ghat. This cliff-like structure. Why? The reason is, look here. I told you about the hot spot regarding the Deccan Plateau. Now see, this is Madagascar. This is Madagascar, this is Africa. This was India. Okay. While traveling, can you see there was a hot spot? Okay. Lava flow took place. Fissure, eruption took place. Okay. And see this dark part? Okay. Layers after layers, layers after layers. Means there was a horizontal arrangement, horizontal bedding. So it becomes very hard, and that is one of it. Okay, chalo, we'll go other. Geological formation of Kutch Peninsula. Kutch Peninsula was an island before. It was not connected with rest of India, this peninsula. So what is the geological formation of Kutch Peninsula? And there was one very important river here, Indus River. Because of sedimentation, deposition, they built a bridge between the continental India and this one, and the peninsula. And it has become a continuous region. Great run, little run. Okay. So geologically, Kutch Peninsula is not part of India, peninsular India. Peninsular India is different from Kutch Peninsula. Okay. Uniqueness of Cauvery River. What is the uniqueness of Cauvery River? Anyone? See, in India, among all the rivers in India, more than 90% utilization is in only one river, and that is Cauvery River. Why? Because Cauvery River, where is Cauvery River? Cauvery River is in the southern part of India. In southern part of India. It will be somewhere here. 90% utilization. Why? Because this river has been fed by southwest monsoon, at the same time northeast monsoon. Okay, if the river is here, that facility cannot be enjoyed by this river. But because of this river locating on the southern side, coming under the effect of the northeast monsoon, if the river is here, no effect of monsoon, northeast monsoon, that is the monsoon that happens in the winter months. So Cauvery River is one of the most 90% utilization, and that is because of the reason very simple: southwest northeast monsoon. Inland drainage of India, you will find what is inland drainage. Inland drainage is when the flow of water does not go and meet the sea or large body of water or the ocean, but remains inside. That is called inland. In India, you will find in two places. One is in Ladakh region, other one is in Rajasthan, Sambar like that. Okay. nature and relation between soils of northern plain and plateaus with parent rock. There isn't any relation between the soil of the northern plain and the parent rock, because majority of the soil in the northern plain is formed by the transportation of the sediments from the hill. So is there any relationship? No, no relationship. But on the other hand, in the plateau, in the peninsular region of India, there is a complete, matching between the what? Nature of the soil and the parent rock. Because it's an all river. Erosion does not take that much. Erosion isn't so prominent. At the same time, the rocks are very hard. Because the peninsular India is formed by archean landmass. So it is one of the most oldest. So this kind of relationship, peninsular type of soil are known as sedentary soil. Okay, this term, remember this term, it's known as sedentary soil. On the other hand, the soil that has been formed on the northern part of India, that is Indo-Gangetic plain, they don't have any relation with the parent rock, because that has been formed by the transportation from the upper Himalayan region, and that type of soil is known as transported or azonal. Why azonal? Go and find out, okay? Now, explain the physiographic factor influencing the climate of India. What is the physiographic factor that is influencing the climate of India? Physiographic feature. See, in a very simple term, one is Western Ghat, Himalaya, Aravalli. So this Western Ghat is affecting monsoon, southwest monsoon. You all know, heavy rainfall, rain shadow region. If there was no Himalaya, Indian climatic condition would have been another story. Suppose, so this is influencing, so you know. So this is how, you know everything, but just the formation of a question. If they ask you, what is the geo factor influencing the climate of India? Aravalli. Suppose if Aravalli were not like this, but like this, Rajasthan wouldn't be a desert. There wouldn't be any Thar desert because of obstruction of the southwest monsoon rainfall, but because of its orientation. So this kind of physiographic arrangement, even the alignments, even the alignment of mountain range plays a significant role. When there is desert, it affects the economy, it affects the people, it affects the landform, climatic condition, many other things. So that is how a physiography can affect the climatic condition and many other related things, the economy, the society, and all. See, influence of western jet stream on northwestern part of India. Economically, this is the factor is the Ravi rock in the northern India. The somewhat light shower they require, then the rig becomes very nice. It has been possible because of western jet stream. Because just remember this, on the winter time there is a disturbance that takes place in the Mediterranean region, and that disturbances or that moisture or that cold needs to be transported to the eastern part of the region, that is the India or the Central Asian region and all. That role has been played by this western jet stream. They bring the western disturbances, okay, and that is responsible for the shower in the winter month in the northwest of India. That is important economically, and also bringing the cold wave. That is the significance, okay. Explain the burst of monsoon, okay. This I will explain. You three or four of you has question regarding this. I will explain to you this. Let me take this. Yeah. See, look. This is a Tibetan plateau. Okay, this is a Tibetan plateau. We have a jet stream. In winter months, this establishment of jet stream is in this direction. Please follow the pointer. Okay, please follow the pointer. the western jet stream will flow like this. It will come like this. It will follow. Okay. What will happen in the summertime? In summertime, this jet stream will flow in this direction, not in this direction. And the height of this Tibetan plateau is something around 4,000 plus. So it will act as a diversion landmass. Okay. So jet stream will go here instead of flowing in this direction. So winter, summer, winter. Most important point is this shifting that does not take place gradually. It's a swift action. Today it will be here, by 2-3 days it will be here completely. It's not like it took completely a month time to shift this. Means it's like this. Western jet stream is flowing up to this place. It means it will flow the entire globe, but the intensity is too much on this up to this place. After 6-7 days it will be here. It will be after 5-6 days again it will be here. By the month time it will be here. It's not like that. Today it will flow here. By 2-3 days it is completely here. Complete absence. That is one of the reasons why there is a crust in monsoon in the Indian continent, because the main point is whenever there is this western jet stream on the southern side of Tibetan Peninsula, there isn't any monsoon in India. You may just follow that. Because there is a direct relationship between upper air circulation and the lower atmospheric condition, which I have already told you. Cyclone, anticyclone, cyclone, anticyclone. So just remember this, when there is a jet stream on the southern part of Tibetan Plateau, there will be no monsoon in Indian Peninsula. Withdrawal of this jet stream to the northern side will establish a monsoon. So now, establishment of monsoon, non-establishment of monsoon. When jet stream is here, no establishment. It shifted here, complete establishment of monsoon. That is why monsoon in India does not build up gradually. It comes at once. By the first 5 or 6 June, it will touch the Kerala coast, and after that, it will cover the entire country. That is one of the reasons. Okay. I hope I clear your doubt. Again, I am explain to you in a little bit detail. Okay. Now, one of the most important point is about the importance of Tibetan Plateau. Importance of Tibetan Plateau on the Indian monsoon. Look, this is a Tibetan Plateau. Its height and its size allow it to act as a heat engine. Because of its size, that is nearness to the source of the sun, and of the size, no obstruction, nothing. It acts as a heat engine. When there is a heating that takes place, wind will, what happen? What will happen to the wind? It will go up, it will warm, low pressure created, it will go up. Now, when it goes up, when there is a low, in upper atmosphere, what will be the type of circulation? That will be anticyclone, because on the land surface it will be cyclone. So in upper atmosphere it will be anticyclone. When there is anticyclone in northern part of the hemisphere, when there is anticyclone, what is the direction? That is clockwise. When there is a clockwise, see, this is Tibetan Plateau. This is Himalayan region. Okay, this is India. This is Bay of Bengal. Okay. Now, not in the surface, but in the upper part of the atmosphere, anticyclone will happen. Do you follow up to this point? Because it is a very important concept. So, anticyclone, upper part, anticyclone flows in this clockwise direction. So, it is not a very small phenomenon. It's a very large, it happens at a very global scale. So, this, some part will come here. But this is not in the surface. Okay, imagine in the upper part of the atmosphere. It will come. This will, some will go here. Some will come down. Now, forget about this part. Let us go with this part. Here is northeast, Nagaland, Manipur, Arunachal, Assam. Now, it will come in this part. This is known as eastern jet stream. That is how eastern jet stream is formed. Okay, now, there is a pre-monsoon shower in the northeast part of India, but no pre-monsoon shower on the other part of India. Any part of India, you won't find a pre-monsoon shower, pre-monsoon rainfall. You will find only in the northeast. And that is very important for tea cultivation and other cultivation. Pre-monsoon shower, you will find only in the northeast. Why? Reason is simple. This easterly jet stream. Establishment or the heating of Tibetan plateau and establishment of anticyclone on the upper part of the atmosphere and development of eastern jet stream. Now, this is clear? Forget it. Now, concentrate on this. Upper atmosphere circulation comes here. At some point, it will go down. Because that is the only direction. The global circulation will happen and from it will go down to the ocean surface. Because there will be high pressure at the ocean surface. Because during this time, the Punjab Haryana plain, there will be a lot of heating that will take place. Low pressure will be created. At the same time, high pressure will be in the water, in the Bay of Bengal or Arabian Sea. This will intensify. The high pressure already there, it will intensify. Means when there is a good formation of anticyclone in Tibetan plateau, it's a sign of good monsoon to India. The intensification of high pressure cells in the Indian Ocean, it's a good sign for monsoon in India. Because if it is high pressure, direction of means the wind will flow swiftly, more strong. So more strong winds means more strong moisture it will carry, more rainfall. Okay, so that is clear about jet stream, about the eastern jet stream, about the importance of Tibetan plateau in the Indian peninsula. Clear? Yes. Okay. Now, why temperature of west coast are comparatively lower than those prevailing on the east coast? Any reasons? Anyone? See, this is the answer. Temperature on the west coast are comparatively lower. See, this one, temperature we are mainly concerned with the latitude. Imagine these two places, one place here, one place here. Same latitude, but temperature on this place will be much hotter or warmer as compared to this place because southwest monsoon is taking place in this direction. Okay, because of the wind direction, the wind brings, yes, and it becomes less. So one of the reasons why in the coastal region situated at the same latitude, but the differences in temperature is because of the direction of the wind, prevailing winds. Okay. Why heat wave in Rajasthan, Haryana, Punjab also? See, heat wave is again a very important section. Heat wave, because many time it is. So see, so heat wave in Rajasthan, Haryana, Punjab. That is because of continentality. On the peninsular India, heat wave does not happen. Okay, hold on, because there was heat wave related casualty in AP also, which is in peninsular. But I'm coming to that point. Assume in peninsular region we don't have heat wave because of the marine effect. Means the marine region are moderating effects. Okay, they bring moderating effects. But in Punjab Haryana region, because of the continentality, high temperature. But there was a date in this Orissa AP region. Why? Because this warm heat or the wave of the heat that has been generated extended to this part, and the marine effect was negated by this kind of heat wave flowing from the northwest part of India. We have this many names, nor'wester, you might have heard about. Okay, nor'wester and many other, and that is one of the reasons why heat wave is prevalent in AP and Orissa region. See, this is the basic definition. In PowerPoint, you can just refer it.